So next we're going to switch our attention and our focus, and we're going to think about theoretical probability. So if each outcome of an experiment has the same chance of occurring as any other outcome, we say that outcomes are equally likely outcomes. Theoretical probability is going to be determined through a mathematical study of possible outcomes that can occur for the given experiment. It looks very, very similar to our rule for our empirical probability. The number of outcomes favorable to event E divided by the total number of possible outcomes. The difference is here, again, these ideas are based on what should happen in theory, not what's just going on in a single experiment. So kind of one important thing to make note of here, for the remainder of this chapter, when we see the word probability, we're going to be assuming that we are talking about theoretical probability. So we're going to be focusing on finding our probabilities using mathematical theory. Right, so for example 4, we're going to talk about rolling a die. Theoretical probability example. A die is rolled, find the probability of rolling, and we're going to go through a bunch of different cases. So the first one, we're asked about the probability of rolling a 3. Unless we're told otherwise, we're going to assume that the die is a 6-sided die that has the numbers 1 through 6 on there. So that means that we have exactly one number 3 on our die. So the probability, I'm just going to call this event A because this is example A, is going to be 1 out of 6, or if we write it as a decimal rounded to 3 places, 0.167. Probability of rolling an even number. So this will be event B. There are 3 even numbers, 2, 4, and 6, out of 6 total. Right, 3 over 6 reduces nicely to 1/2, or 0.5. Right, a number greater than 2. Right, so on our die we have the numbers 3, 4, 5, and 6 that are greater than 2. So that's 4 of our numbers are larger than 2. That reduces to 2/3, or 0.667 if we round to 3 places. The probability of rolling a 7, well, if we're only looking at one die, that's impossible. Right? So we're only looking at one die, that's impossible, so our probability of something that is not going to happen is going to be 0. Right? A probability of a number less than 7, well, all 6 of our numbers are less than 7. So as a fraction, it would be 6 out of 6, which then just reduces nicely to the number 1. So when we're thinking about probabilities, again, we're thinking about calculating these. These are theoretical probabilities, and these are things that we want to keep in mind. On the next page up at the top, there is a brief list of important probability facts, which we just saw in our last example. The probability that an event cannot occur is 0. If it must occur, it's 1. Think about 0% or 100% if it's helpful to you to think about these in percents. Every probability is a number between 0 and 1 inclusive. So our probabilities have to be between 0 and 1. They cannot be negative. They cannot be more than 1. Right? We cannot range out of the 0% to 100%. And the sum of all probabilities and all possible outcomes in an experiment is also equal to 1. So as we're thinking about going into our next example, this is going to be something that we're going to use in our next example.